Okay, so good morning once again. Today we're going to continue our discussion on multiple linear regression. We were using the wage dataset consisting of 526 observations of 8 variables. Now, last time, what we did was to model our, do our simple linear regression where we were trying to explain the hourly wage and use education as the predictor. Now, we said that our data set consists of 3 variables that are categorical. Okay, education is in years, experience is in years, tenure is a number of years, number of dependents. This is also quantitative. So there are 3 variables here: race, gender, and civil status, that are categorical in nature, and which we used as a factor or a classifier last time. Hourly wage is our variable of interest. This is our dependent variable. And then last time, what we did was to predict or model hourly wage using education. That was our model 1. And then we also had another model 2 where we used all the other variables, including the factors. So just a quick review of what we have done, guys. We first converted the race, gender, and civil status as factor. And then what we did was to create a model. We called it model 1. We used the function LM, linear model, where we regressed hourly wage on education. Okay, and this generated a regression output, a summary, model 1. Okay, so we can find here the individual t-test of the parameters of the intercept and the education. The intercept is not statistically significant, but we still include that in our model to predict our dependent variable. Education is highly significant, and we learned last time that the meaning of this 0.54 is that this is the marginal effect of a 1 unit increase in education on our dependent variable, ceteris paribus. So the ceteris paribus here does not mean anything actually, because we only have 1 predictor. So this means that for every 1 year increase in education, there's a corresponding 54 centavos increase in hourly wage, ceteris paribus. Okay, and how about the overall goodness of fit? Okay, we can see that here. Our overall goodness of fit is the adjusted R squared. This means that our model can explain 16.32% of the variability of your dependent variable hourly wage. Okay, and our ANOVA, this is the overall goodness of fit, and it's statistically significant. And if you recall, guys, ano yung hypothesis natin dito? Our hypothesis here is beta null is equal to beta 1 is equal to 0. Kasi dadalawa lang naman yung natin, no? Parameters natin, yung intercept at saka yung education. But if we have several, it will be beta null is equal to B1 is equal to B2, etc. is equal to 0. And what's our conclusion here? What's our inference here? We reject the null hypothesis that B0 is equal to B1 is equal to 0. We reject that. We reject that all the parameters are equal to 0. There's strong reason to believe that at least one of these is not equal to 0. Okay, and that's your education. Ito yun, 0.54. Hindi siya equal to 0. And in fact, the p-value is significant at the 0.001, at the 0.1% level, 0.1% level of significance. Okay, all right. So we can also generate the output using, for example, a library ko lang from JTools. Okay, you can use this JTools output, which may iba pa no, yung GT summary, which I'm going to also show you in the future. Okay, ito yung output natin. So this is a lot better than the one that we generated a while ago na hindi magandang format. This is already a format that can be used for papers. Intercept, education, estimates, 2 decimal places. Okay, andito yung model fit natin. F, degree of freedom 1, this is for your predictor, ilang predictor siya. Degree of freedom 2, this is your n minus k minus 1. Okay, it's equal to 103.36, that's your F stat. The P is equal to 0.00. So this leads us to conclude that we reject the null hypothesis that BO is equal to B1 is equal to 0. And then we have the R squared at 0.16, practically the same as your adjusted R squared. Okay. All right. So we said that we don't stop here. Kasi we have to analyze the residuals. Kailangan magda-diagnostics tayo. So the way to go about the diagnostics is to study or analyze the residuals. Yung residuals, guys, ang tinitingnan natin pag nag-diagnostics tayo. Okay, so if we plot this, tingnan natin itong plot natin. This is making use of the base R plot function. We're plotting on the x-axis your education, on the y-axis your hourly wage. Then the label on the x-axis is years of education. On the y-axis, the label is hourly wage. Plot character natin, yung maliit na circle to na black. And then frame is equal to false. Huwag lalagyan ng frame yung plot natin. The main plot of the plot is scatter plot of education and hourly wage. Then lalagyan natin ng axis ng sa axis natin, 1, this is on the x-axis, 0 up to 20, increments of 5. And then we're going to put a line, okay? The line should be the line of the regression of the hourly wage of education, and the color is equal to blue. Okay, so ito guys yung code chunk na to that gives us the plot of your independent variable education, your dependent variable hourly wage, and then may mga labels siya, okay? And then the some modification in the x-axis and the regression line. AB line, anong line yan? Okay, it can be a horizontal line or vertical line, pero ito yung regression line, LM. Okay, running this. Okay, so this is our, oops, ano nangyari? What happened now? AB line. Okay. Kasi ito hindi niya. This should be wage. Hindi na basa yung ano. Remember guys, hindi na re-recognize ni R itong hourly wage kasi wala siya dito sa mga objects natin, no? Unless, when will this work, guys? Review nga. When will this work? Itong code na to, guys. When will this work? Anyone? When will this work? Hello, guys. Hindi nag-work yung AB line, guys. Pero yung plot natin, nag-work siya. Kaso wala yung regression line. Wala yung regression line. Nag-work yung yung axis natin, yung x-axis. Okay, x-axis sequence from 0 to 20 by 5. When will this work, guys? Anyone, please? Any suggestion? Hello? Somebody wanted to answer a while ago. Yes, thank you, Rhea. Rhea, paki-chat sa lahat. Sagot mo. Rhea, kindly share your answer to everyone. Yes, correct. Rhea is correct. Thank you so much. Kasi R was not able to recognize this hourly wage. If you take a look at the global environment, wala siyang non-existent to. It's a variable in the wage function. So you either put here wage for hourly wage, and then dollar hourly wage, and then wage dollar education, or sabi natin we can use the attach and then wage. Okay, we can do this. Sige, i-run natin to. Okay. So, nag-work na siya. Kasi naintindihan na ni R kung sino tong ano na to, sino tong hourly wage na to. Okay? All right. So let me just detach, no? Detach ko na lang ulit yung detach ko na lang ulit si wage. Detach wage. Okay. All right. So we have we created an object called mod1. Yung mod1 na ito, guys, di ba ito yung ano natin? Ito yung object natin na create for our regression. And then it's interesting, guys, yung mod1 na yan, maraming laman yan. It's a list actually. Sabi natin, di ba, if you recall, yung list, guys, it's an object in R that can accommodate different types of data. Pwedeng numerical, pwedeng character, pwedeng vector, pwedeng another list, no? So, marami siyang ma-accommodate na data. Dali lang, guys, excuse me lang. Okay, so if you take a look at mod 1, yan, no? So it consists of, andyan yung coefficients niya, guys. Yung coefficients, yung parameters natin. This is the intercept, negative 9.05. This is the value of education, marginal impact of education on our wage. Andito din si residuals. So you can actually access this. We can access yung mga object na yan. So let's just show that. Okay, ito, no? Names. Okay, ito yung mga laman niya. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4. So 9, 10, 11, 12. 12, no? Sabi nga dito, list of 12. Then we can access the residuals. No? So for example, rest. Let's create an object called rest. And then it will be the residuals coming from the mod 1 model. Yung residuals natin, this is the difference between the predicted value and then the actual value. Kasi meron tayong, nasan dito yung residuals, fitted values. Yung fitted values, guys, ito yung value ng model natin. Ano ba yung model natin? Di ba yung model natin? Quick review lang, guys, no? Para it pays to review them. We're modeling hourly wage kasi, di ba? Hourly wage is equal to ito, no? Your intercept, Control C, Control V, plus your Control C, your parameter, times your education. Okay, so this is our model. Okay, plus an error. Error, guys, kasi magkaiba yung actual value ng hourly wage at saka yung fitted value natin. Ito yung fitted value natin. Okay? So, para mawala yan, guys, yung 18 na yan, yung error, hindi nga, in fact, hindi nga yan, no? Kasi hindi naman time series, sorry. Okay, let me E sub I. No? T kasi usually ginagamit kapag time series. Hindi naman tayo sa series, kaya E sub I. Okay? So, now, yung predicted natin, guys, is actually hourly wage hat, no? May symbol na hat dito. Is equal to, this is equal to Yan, no? Paglagyan natin ng hat to, ibig sabihin predicted value yun, mawawala na yung epsilon sa P sub I natin, yung error term. Kasi guys, yung hourly wage na hat, this signifies your fitted value. And it's equal to 0.90, negative 0.9 plus 0.54 times your education. Okay. Is there any question with that, guys? I hope clear siya. I'm going through this fast kasi na-discuss natin to dati. No? Any questions, guys, with that? Chat naman kung clear so far. Let me wait for the others to give their... Okay, thank you. Okay, iba hindi sumasagot, sana sumagot yung iba. No? Okay, so we can generate this object. We can create an object out of the model 1. Kasi model 1, sabi natin guys, it's a list. Thank you. Okay, thank you for those who are responding. Model 1 is an object, it's a list consisting of several data types. So here, I'm creating an object called res, and then I'm telling R to get from model 1 the residuals. If I tanggalin ko na yung ano, para hindi nila i-print. Tapos dito na lang. Yan na lang guys. Para ma-view niya. Yan. Ito yung mga ano, no? Ito yung mga residuals. Ito yung mga error terms. These are the error terms of our model. And then, we can also get the fitted values. Para hindi niya i-print, guys. View. Predicted. Okay? Mas maganda sana kung res 1 to. No? Res 1, pred 1, res 1, pred 1. Which means para sa ano siya. Dito na pala yung view. Ano? Okay, sorry about that. Okay, so ito yung mga predicted value. Okay, where did you get this predicted value? From here. From here. It's negative 0.9 plus 0.54 times education. Ano ba yung number 1 ng education? Ito ba yung medyo nagkamali tayo? Education is 11. Sige nga, let me try. Okay, so 0.9 plus 0.54 times education is 11. Yan. Okay. 5.04, that's our predicted value. Yan. Approximately 5.04. And then the residual is Control C, Control V. Ito yung predicted, no? Ano ba yung actual value? Wage natin. Ang actual value natin is 3.1. So actual value is 3.10 minus, ito yung actual value. Ito yung predicted value, 5.04. Therefore, ang residual natin around 1.94. Okay, yan. Negative 1.94 times. Okay, guys? Clear ba? Chat naman please kung clear. Sana naiintindihan natin po guys. Kasi it's not enough for us to know na nag-generate ni linear model ng residuals, yung fitted values, but we should know where they came from para clear sa atin yan. Okay, good. Good. Thank you. Thank you guys. So, in Excel, kaya natin itong gawin. No? Pero, ang importante sa atin, if we were forced to do that, guys, we can generate it. Pero ito, automatic na generate in R for us. Okay, and then, okay, good. Okay, so quickly, guys, let's just go through this. Kasi, apologies guys for having to go through this kasi 1 week tayo hindi nagkita, and then there's a great chance, especially kung hindi nyo binuksan yung notes nyo nung the past week, na medyo nakalimutan nyo ng konti. So it pays to review. No? Pays to review. So merong package called Broom. Okay, a very good package. So ano ba yung ginagawa nitong Broom? So pag package usually dalawa. Yan natin guys, just to review ano yung contents itong Broom package na to. So we can make use of sa Broom package, merong augment na function. Let's just wait for this Broom, which will generate yung metrics ng ng linear model natin. So we're creating here an object called mod1. Okay, mod1 diagnostics metrics. Of course, you can name this differently. And then we're using from the Broom package the augment function. It's taking long. Broom package. Anyway, sige, habang naglo-load pa siya guys, let's run this. Ayan. Wala. Okay, built under our version. Okay. And then sabi dito, overwritten by may mga functionalities si JTools na in-overwrite ni Broom. Ibig sabihin, itong function na to, which is also found in JTools, in-overwrite ni Broom yan. Okay. Anyway, so let's run this. Okay, so this one is, it's a data frame. Okay, it's a data frame, itong model1 diag.metrics. Okay, so what can we find here? Andito guys yung dependent variable natin, andito yung independent variable natin, andito yung predicted value, andito yung residual, andito yung hat is your standard deviation to ng fitted. Okay, sigma is the standard deviation of your residual. And then your Cook's distance, ginagamit natin to determine if outlier at saka influential point yung natin, yung data natin. And then standard and residual. Okay, sigma is the standard deviation. And then may standard deviation din, standard error ng residual, itong standard.res. Ito yung standard error ng fitted value natin. Okay. Ulitin ko lang yun guys. This is our dependent variable. This is our independent variable. This is our predicted value which was generated from the model itself. Yung negative 0.9 plus 0.50 something times education. Okay, and then this one is a standard error of your fitted value. This one is your standard deviation. This one is the standard error of your residual. Okay, so let's move on here. That it's always important, guys, to plot your residuals. A while ago, we plotted it. Diba? Pinat natin siya dito. Saan na yung ano natin? Okay. So, may plot natin ito. sensitive si ano, sensitive yung let me just run this again, guys. Okay, so what do you have here? This is the plot of your this is the plot of your independent variable education, and this is your dependent variable. It's a bivariate plot, so scatter plot siya. And then this is your regression line. This is your negative 0.9 plus 0.5 something times education. And then ito yung actual points natin, di ba? Itong plot na to, this is your hourly wage versus your year of education for this specific observation. Ito yung ano natin, ito yung regression line natin. So the distance between the actual point to your regression line, that's your residual. Okay? Ito yung mga residuals natin. Yung mga difference between your your actual data point and your standard deviation. Now, so you can see there yung ano natin, yung residuals natin. So let's use this another way to plot the residuals. So let's use the ggplot2. And then we're going to use the object, yung model 1 diagnostics natin. Okay, so this is our data. Ang ggplot2 kasi guys, data plus the mapping, yung aesthetics, kung ano yung nasa x-axis at saka ano yung nasa y-axis, plus whatever geometric object you're going to use. Okay, so here, ang ginagamit natin na data yung generate natin from the Bloom package, and then kukunin natin doon si x-axis, independent variable, education, y-axis, si dependent variable, hourly wage, and then plus geom point. Yung geom point yung scatter plot, and then ipapaano natin yung stat, so plus another layer, stat smooth, LM, no? Standard error is equal to false. Hindi niya ipa-plot si standard error. And then dito, another layer, segment. No? Segment is a step x is equal to education, and then fitted, color is equal to red, size is equal to 0.3. Sige, let's run this. Okay, there. Okay, kindly chat guys if you were able to run this. Okay, good. Good. So this plot, guys, is a plot of the residuals. Yung mga lines na to, yung iba na superimpose sa lang, ano? Kasi nasa parehong ano sila, parehong vertical line. So the red lines there are the lines that represent our residuals. Okay, so this one, for this point, ang residual na to. Okay, so what's being done in linear model, in ordinary least squares, is that the residuals are computed and then it's squared. In a square siya, and then you add all the squared residuals. Okay, you add all the squared residuals, and that will represent your sum of the squares of your error terms or your residuals. Okay, I hope you recall that from your basic stat. All right, so sa Excel guys, mahirap gawin tong plot na to. Mahirap gawin tong plot na to. If you plot DSE is equal to true, tingnan lang natin to guys, what will happen. If we include the standard error of your regression line, let's just plot this. So enter. Yan. Okay, makikita natin dito guys yung confidence, 95% confidence interval natin that are that our model, that the two values of our parameters lie within this band, this gray band. Yun ang standard error natin. Okay. All right. I think we also did this last time, no? Okay, so here, gagamitin natin guys yung ano, you can make use of another package, yung GG45. Okay, this is related to ggplot. And then, mas simple dito kasi AutoPlat na lang. No? AutoPlat, Model 1. Dito kasi, dito, medyo marami pa tayong inano dito, plinat. Pero dito, we can make use of the GG45. Let's record this first. Okay. Before we plot that, ito muna, no? Okay. We're going to create, ipapartition natin guys, 4 na objects, 2 by 2, 2 rows and 2 columns. Ipapaplot natin yung model 1 itself. Let's see what will happen. This is used for diagnostics, no, para makita natin yung behavior na residuals natin. Okay, let's take a look at this. Yan. Okay, this is useful guys for residual analysis. Sabi natin, you just don't generate the model. Pagka ano natin ang model, tapos na yun. Hindi ganon. In your previous statistics subject, siguro ganun lang. Pag na-generate yun na yung multiple linear regression, tapos na. In fact, tatanggalin nyo na kagad lahat ng mga insignificant variables. Tapos, interpret na lang, tapos na. But not in our case, kasi this is, we need to dig deeper and dive deeper and make sure that we test for the assumptions of your classical linear regression model, di ba? Yung mga assumptions na sinasabi natin, yung linearity in the data, linearity in the parameters, homoscedasticity, heteroscedasticity, right? Di ba yung mga parameters natin, so that autocorrelation, multicollinearity, so that our parameters, the estimates of our parameters are blue. Ano ibig sabihin ng blue? Yun yung best linear unbiased estimator. Okay? Kasi kung mababiolate, for example, yung rule, yung homoscedasticity assumptions, then anong mangyayari sa kanya? Malamang hindi na siya yung best. Okay? Hindi na siya yung best na linear estimator natin. Okay, so we have here several plots. If you take a look guys at the x-axis and the y-axis, lahat ng mga nasa y-axis, you notice mga residuals yan. Okay? Residuals. Whether it's standardized residuals, square root ng standardized residuals, yung nasa x-axis siya nagbabago. So dito fitted values, ito quantiles, and then dito yung leverage. Okay, what's important for us is not really how this was computed, although we can do that. Ito, madali lang naman to, no? Prinat lang si fitted values, yung predicted values at saka si residuals. So sabi natin, dapat, pag prinat natin yung residuals, ang behavior na dapat, homoscedastic dapat yung error terms natin. When we say homoscedastic, it means that the variance should be constant. Ito guys, when you take a look at this, okay, for example, at this level ng fitted values natin, ito lang yung variance yan. Pero as we move towards the right of your fitted values, nagbabago na yung variance niya. Okay, ito, ang lalaki ng variance. So you have here a case where the variance is not constant. In fact, nagpa-fan out siya, no? Lumalaki siya over time. So this is indicative that our residuals are heteroscedastic. And if the residuals are heteroscedastic, then it violates the assumptions of classical linear regression model. So the term for that is aayusin natin, remedied, no? It has to be remedied. So, ang assumptions ito, baka may kulang sa ano natin, may kulang sa meron tayong what we call omitted variable bias. Ano yung omitted variable bias? Yung model natin is lacking a very important variable in explaining our dependent variable. Remember, our dependent variable is hourly wage. Ang ginamit lang natin sa education. Ang sinasabi sa atin ito, baka may mga iba pang variables na pwede natin magamit para i-explain si hourly wage. Kasi education lang yung ginamit natin. So ito guys, no? Ito, important to, no? Itong ano naman, itong normality of the residuals, okay? Although hindi naman siya talagang requirement, it's more of an optional requirement, yung normality na residuals. But as it is, guys, at face value, this is showing to us that hindi normally distributed yung residuals natin. How do we know that, guys? Look, itong quantile plot natin. Dapat yung mga residuals natin, yung mga standardized residuals natin, dapat hindi siya lumalayo dito sa quantile plot natin, sa QQ plot. But you can see here that especially doon sa mga values na malalaki, no? Yung malalaking hourly wage, medyo ano guys, medyo malayo, no? Medyo malayo siya dun sa normality. Okay? So we can use this as a plot, but later on gagamit tayo ng statistical test para boost pagan, no? Para mapakita kung statistically talagang normally distributed yung residuals natin. Okay? So ito naman guys, si Cook's distance, ano to, pinapakita sa atin kung merong leverage or influential points. What are influential points? Okay, I think we discussed this initially last time. Sabi natin kasi yung mga observations natin, it can be outliers, okay? Pero kahit na outlier siya, pwede naman siya hindi maging influential point. Ang influential point ang binabantayan natin guys, kasi ang influential points, it can really change the output altogether, the regression output, kung tatanggalin natin yung influential point na yun. Okay? But that begs the question also, should influential points be removed? And so, ano yan, medyo ticklish issue yan. Kasi, what if that influential point, tama naman yung pagka-record sa kanya. Tama naman talaga na yung observation, tama naman talaga. So, if we remove that, there's a chance na it might not be reflective of the nature of your data. Okay, kaya pag-usapan natin yung influential points yan as we go along. Okay, ito din guys, it's also a picture of our heteroscedastic na or homoscedastic na residual distribution. So ganun din dito, similar din siya dito sa taas, no? Ang difference lang ito, standardized yung ginamit natin dito instead of just the plain residuals. Okay, so let's continue with this, guys. Right? Another alternative to this, yung plot na to, plot ng model 1 is this one. Itong AutoPlat na to, where we make use of GJ45 AutoPlat. Tignan natin to. Yeah. Okay, same lang guys. Same lang siya, but I prefer this one to this other one that we, kasi mas sa akin mas maganda yung ano niya, yung pagka-plot. Okay. So may mga explanation dito guys na I already explained to you. Okay, so please peruse over that. All right. Okay, so question lang guys, did we do model 2 last time? Check ko yung video natin na I think we discussed this, di ba? Okay, yes nga please or no? Can you chat please guys? Yes, kung ginawa natin model 2 last time. Okay, good. All right, let's just quickly review this. So dito, nag-create tayo another object, mod 2. No? Again, this is a linear model. We are regressing hourly wage on education, experience, tenure, race, gender, civil status, plus the number of dependents. So 1, 2, 3, 4, 5, 6, 7. 7 yung predictors natin, yung data natin, yung wage. Okay, 7 predictors. Now you can spell it out or you can just use this LM, hourly wage, tilde, and then dot. Ibig sabihin ng dot na to, lahat ng predictors. Okay, so they will yield the same results. So let's just run this model 2. Naran ko na siya. So pakirun ulit guys. And then summarize ko na lang ulit siya. Summary model 2. Okay, and this was our output last time. So I think we discussed this in greater detail last time. Now, you notice now that we have here 3 categorical variables that are factors. Factor, race, gender, civil status. Si R, ang pag-generate niya, guys, race, notice may nakalagay na white. Ano ibig sabihin ng white na to, guys? That when you interpret this, okay, this refers to the white, okay, but this should be interpreted in relation to the benchmark variable, which is the variable that is not stated here. So si race, guys, dalawang variables yan, dalawang levels, si white at saka si non-white. So ang ginawa ni R, nag-default siya na yung ginawa niyang benchmark yung alphabetically that will come first, the level that will come first, which is non-white. So yun ang gagawin niyang value is equal to 0. Tapos si white, ang gagawin niya is equal to 1. So sa Excel, guys, kung titingnan natin to, this will now appear as race. Tapos lahat ng white, 1. Lahat ng non-white, 0. And when you interpret this, it's always interpreted in relation to your benchmark, which is the level that's equal to 0. Okay, so ano ibig sabihin itong 0.10996? So we studied this last time. It means that on the average, white employees tend to receive around 11 centavos more kasi positive to, no? In terms of hourly wage compared to their non-white employees, no? Okay, so bine-benchmark natin dun sa benchmark level natin, which is non-white. And paano ko nalaman, guys, na non-white yung benchmark? Ang default ni R, kung tingnan natin, guys, lahat ng mga levels, yung alphabetically that will come first, that will be your benchmark, no? And also another one is nakalagay dito kung what does this estimate refer to? It refers to white in relation to your non-white. Okay, so ito naman si gender, male. So therefore, ang benchmark natin si female. So 1.76, no? Ibig sabihin nito, okay, on the average, male employees tend to receive $1.76 more in terms of hourly wage compared to their female counterparts, ceteris paribus. Okay, as we note, guys, female comes first alphabetically compared to male. So si female ang ginawa niyang benchmark, aka ginawa niyang 0. Okay? So si male ang ginawa niyang 1. So ang lalabas dito, guys, yung value na estimate ng male in relation to female. Okay? And we said last time that if there are, let's say, 5 levels, ilang dummy variables ang gagawin niya? It's always the number of levels minus 1. Okay? So, kunyari, 5 levels, A, B, C, D, E. So, ang mangyari dito, kunyari, variable A, B, C, D, E. Okay, so since si A yung alphabetically mauuna, siya yung gagawing benchmark. So, ang lalabas lang dito, guys, let's assume the name of the variable is var B, okay, var C, var D, and var E. Yun ang lalabas dito sa guys, sa regression output natin. Okay, what I'm saying here, guys, what am I saying here? What I'm saying here is that you have a variable called var. Tapos yung var na yon, categorical siya. So we can use it as a classifier. So ang ginawa natin, kinonvert natin siya into a factor. As that factor natin siya. So when we regress our variable of interest, ang lalabas dito guys will be var B, var C, var D, and var E. That means apat yung yung mga outputs natin dito. Minus 1 yun. Bakit minus 1? Kasi the other one will be the benchmark. Okay? Pag sinama pa yung var A na yan, magkakaroon tayo ng what we call a dummy variable trap. Okay? So hindi pa pwedeng gawin yun guys kasi magkakaroon ng multicollinearity yan. Magkakaroon ng dummy variable trap. So that cannot be done. You cannot introduce 5 dummy variables if you have 5 levels. Okay? So dito guys, sa race, dalawa lang, isa lang, sa gender, isa lang, sa civil status, isa lang. Bakit tig-isa lang sila guys? Bakit isa lang yung dummy variables dito? Kasi nga, si race, dalawang levels lang yan, non-white at saka white. Si gender, dalawang levels lang yan, female at saka si male. Si civil status, dalawang levels lang yan, married at saka single. So tigi-isang dummy variable lang introduce, tigi-isang lalabas ang dito ng output. And then how do we interpret this? Always interpret this in relation to your benchmark variable. So here, we can say here that on the average, single employees tend to receive 46 centavos less, 46 centavos of hourly wage less than their married counterparts, ceteris paribus. Okay? Of course, the assumption here, guys, is that these are significant. Pero kung titingnan natin, guys, ang significant lang si gender. So walang kinalaman, guys, in this case, si race, dun sa hourly wage. Hindi siya significant. It doesn't matter whether white or non-white ka. Hindi siya lumalabas ng significant. Si civil status, hindi rin siya significant. P-value is 0.12. So that's way bigger than 0.05. So we will reject the null hypothesis that B01, 2, 3, 4, 5, 6, B6 okay, is equal to 0. Remember guys, ito may mga hypothesis to. B0 is equal to 0, B1 is equal to 0, B2 is equal to 0, hanggang B7 is equal to 0. So this is what we call the individual tests of our parameters. Ito naman guys, ito, overall goodness of fit test natin to. Remember, yung ANOVA natin. Okay, iisa lang yung dito, iisa lang yung hypothesis natin. B0 is equal to B1 is equal to B2, ... is equal to B7. Okay, yung 7 na variables, okay, 7 na parameters, sine-check natin if they're all equal to 0. Ang conclusion natin, ang inference natin, we reject that null hypothesis that B0 is equal to B1 is equal to B2 is equal to B7. Nire-reject natin yun kasi our p-value is less than 0.05. Okay? And then we have here some stat, 7 degrees of freedom. 2 degrees of freedom guys kasi pag ANOVA. Saan galing itong 7? DF1. Why is it DF1? DF1 is equal to 7 degree of freedom. 1 is equal to 7 because there are 7 IVs. There are 7 explanatory variables. Okay, ano yun? Education, experience, tenure, race, gender, civil status, and number of dependents. Okay, so 7 yan. No? That's why there are 7 degrees of freedom and 518 degree of freedom too. Okay, saan nagaling 518? N minus K minus 1. Ano yung N? 526 observations minus K, yung 7 minus 1 to compensate for the intercept. Kasi intercept, kinukompute din natin yun. So 526 minus 7 minus 1, that gives us 518 degrees of freedom with p-value is equal to less than 0.005. Therefore, we reject the null hypothesis na lahat ng parameters natin equal to 0. Okay, multiple R squared, 37%, adjusted R squared, 36%. Ano ibig sabihin nito? It means that 36% of the variability of your of your outcome variable, which is hourly wage, can be described, can be explained by all our parameters. Okay? Notice na kanina, yung mod 1 natin, ilan lang yung ano natin, ilan lang yung, how much was our adjusted R squared? Only around 17%, I think. Yeah, 16% lang. Okay. This time, here for our model 2, there was an increase in your adjusted R squared. 36% yan, guys. So that's always expected. Pag nagdadagdag tayo ng explanatory variables, laging tataas yung adjusted R squared. But there will come a point, guys, na kahit na dagdag tayo ng dagdag, no? Wala nang effect yun. Tumataas yung adjusted R squared, ito, tumataas yung multiple R squared, but your adjusted R squared will go down. So ang importante sa atin yung adjusted R squared, not the multiple R squared. Ito importante to, guys, for multiple linear regression. Okay? Kasi kahit na dagdag ka ng dagdag ng explanatory variable, kunyari, ang gamitin natin 100 na explanatory variable, kahit na iba dun, wala namang kinalaman dun sa dependent variable natin. The model with 100 variables will have a higher multiple R squared than the one with only 90 independent variables. Kasi nga, lagi guys, pag nagdadagdag tayo na nagdadagdag ng independent variable, laging tataas yung multiple R squared. However, okay, that's why this is not relevant with respect to adjusted R squared. Kasi yung adjusted R squared, guys, ang ginagawa niya, minimeasure niya yung variance na kayang i-explain with a penalty on the number of predictors. So, mananotice natin, guys, pag nag-compare tayo ng model, titingnan natin yung adjusted R squared, not the multiple R squared. Okay. Okay, so sorry guys if I seem to be going fast kasi quick review na lang to, no? So ito guys, ito ang mga ano natin, ang mga ano natin, significant variables are education, experience is significant at the 10% level of significance, no? At 10% siya. Si tenure, si gender, they're all significant at 3 stars, ibig sabihin significant at 0.1%. But the rest are insignificant. Okay, in your previous stat, siguro ang ginawa nyo, tinanggal nyo lang lahat ng mga insignificant. Tapos, yun ay final model nyo. So you come up with your model that hourly wage is equal to negative 3.38 plus 0.57 times education. Kung isasama natin to, plus 0.02 times experience, plus 0.14 times tenure, okay? And then plus 1.76 times gender, and then we ignore this other two. Ang ini-ignore natin 1, 2, 3. Yung tatlong yan, tatanggalin natin. Okay, but that should not be the case, guys, which I'm going to explain now. That's not the right procedure. Okay. Right. So what we're going to do now is i-compare natin quickly dalawang models ang generate natin, di ba? Si Model 1 at saka si Model 2. Si Model 1, guys, ito yung tinatawag natin na restricted model. Bakit restricted? Kasi ito lang yung only one, di ba? Only one independent variable. Ito naman with 7 IVs. So si Model 1 natin, isa lang yung ano niyan, isa lang yung independent variable natin sa education. Okay? While on the other hand, si Module 2, 7 yung ano natin diyan. So kung sino yung mas konti na independent variable, ang tawag natin sa kanya, ito yung restricted model. Okay? Ito naman yung unrestricted. So careful tayo dito, guys, ha? Yung unrestricted at saka restricted, it's based on the number of independent variables. Hindi yung Model 1 or Model 2. Hindi yung pangalan na yun. Generic lang yung Model 1 or Model 2 yan. Okay, if we run this, okay, we can see now that okay, ito BIC, sorry. Okay, so based on AIC, Model 1 has 277, Model 2 has 2640. So, yung information criterion, guys, ang ginagamit natin dyan, AIC or BIC, meron pang iba, no? SBC, meron pang iba, but we'll just focus on AIC. And then, the lower the AIC measure is, ito kasi information loss, no? The better. So dito, 2640 versus 2077 or 2679 versus 2790. So, consistency, both AIC and BIC, that Model 2 is the more superior model than Model 1, having a lower AIC or BIC. Now, statistically, pwede natin i-test yan using this function ANOVA. No? So ANOVA, Model 1, Model 2. Okay, remember Model 1 is our restricted, Model 2 is our unrestricted. And ang null hypothesis dito, mas maganda si restricted model. Okay? Mas maganda si restricted model kaysa sa unrestricted. Let's run this. All right? So this is our restricted model. This is our unrestricted model. And our null hypothesis is that our restricted model is better. And you have this p-value less than 0.05, in fact, significant at 0.1% level of significance. Okay, so we reject the null hypothesis na mas maganda yung Model 1. Turns out, guys, mas maganda si Model 2, no? Yung unrestricted. Pwede bang i-ano to, guys? Pwede bang, will it matter kung magkabaliktad yung ano niya? Run natin, guys. Okay. So, ano ginawa niya dito? So, binago lang yung order, pero ganun pa rin yung null hypothesis natin. Our null hypothesis is still that the restricted model is better. So, we reject that. No? We reject the null hypothesis that the restricted model is better. Therefore, yung unrestricted, yung mas maganda natin. So, mas maganda si Model 2. Okay. Alright. Ano yung next step ngayon, guys? So, si Model 2 mas maganda, ibig sabihin ba nun, tanggalin na natin lahat ng ano? Tanggalin na natin lahat ng, ng mga insignificant variables. That's not true. No? Ang ginagawa natin, guys, is a process called stepwise regression. So what's stepwise regression all about? Stepwise regression is removing your variables or adding your variables, depende, kasi pwedeng forward or pwedeng backward. Ang ginagamit natin dito yung backward stepwise regression. Ano kaibahan nila sa backward at sa forward? So we're going to discuss later on. Si backward, guys, we start with the full model and then tatanggalin natin isa-isa. So what's the basis of the of what we call the leaving, LEAV? May aalisin tayo ng variable. Ano yung basis ng leaving variable natin? Ang leaving variable natin will be the lowest absolute T-stat value. Okay? So we're going to look at the T-stat. Yung pinakamababa dyan na absolute value, okay, yun ang tatanggalin natin kasi yun ang least na significant na predictor. So dito, ano ba yung mga ano natin, candidates? Race, civil status, non-debt, so isasama pa natin sa experience, pero ito significant at 10%. So ito, 0.257, negative 1.556, number of dependents is 135. So you get the absolute value of that, disregard the negative symbol. Ang pinakamaliit dito is race white kasi 0.257 siya. Therefore, this will be our leaving variable. Aalisin natin. So we're going to delete, remove race dun sa ano natin, sa model natin. Okay, so let's go here. Ito na, no? Okay. So LM na tayo, hourly wage, education, experience, tenure, gender, civil status, number of dependents. So naging 6 na lang siya. No? Naging 6 na lang siya. Tinagal natin si race. Kasi si race yung naging living variable natin. Okay? So pareho lang din yung natin, yung format, yung formula ng LM, tinanggalan natin si race. Okay? Bakit natin tinagal si race? Kasi siya yung variable with the least na absolute value ng t-stat. Siya yung pinaka-least na may predictive power over hourly wage. Okay. So another way to do this is, ito din, pareho lang yan, model 3, LM, hourly wage, lahat, and then i-minus mo si race. Hindi kasama si race. So pareho lang yung output ng guys. Okay, let's run this. Okay, so may model 3 na tayo. No? It's also a list of 13 objects. Summary natin. Okay, so we now have our our output. Yan. Okay. So si education and then experience is still significant at 10%. Tenure, gender, okay, civil status, number of dependents. Okay, hindi sila significant yung dalawang to. Okay, what happened to our model? Okay, 36.31%. Tumaas ba yung adjusted R-squared niya? Kanina, ilan yung adjusted R-squared natin? $36.19. No? Dito, 36.31. So there's a slight increase in the predictive power of our model to describe or explain our outcome variable hourly wage. Okay. So again guys, titingnan naman natin to, no? Ano ibig sabihin ng education na to? Okay, it means that for every 1 year increase in education, there's a corresponding 57 centavos increase in hourly wage. Okay? Ceteris paribus. Okay, ito naman experience. For every 1 year increase in experience, there's a corresponding 2 centavos increase in hourly wage. Okay? Kama, ceteris paribus. All things being the same. Ibig sabihin ng all things being the same, guys, huwag yung dadagdagan sa education, huwag dadagdagan sa tenure, huwag dadagdagan yung ibang variables huwag natin dadagdagan sila. As is pa rin sila. Okay, so here, gender male, tenure then significant. There's for every 1 year increase in tenure, there's a corresponding 13 or 14 centavos increase in hourly wage. Ceteris paribus, or all things being the same. Statistically significant siya. Ganun din si gender male. But again, this is a factor. So how do we interpret this? On the average, male employees receive $1.76 more than their female counterparts. Ceteris paribus. Okay? And then si single, guys, hindi significant. Si number of dependents, hindi significant. Okay. Now let's compare, guys. Let's compare si model 2 natin at saka si model 3. Sino mas maganda sa kanila? So let's do this. In terms of AIC, in terms of adjusted R-squared, di ba mas maganda si model 3? Mas mataas yung adjusted R-squared niya. Let's see in terms of AIC. Kasi AIC, 2638 for model 3, 2640 for model 2. Model 3 has a lower AIC. So in terms of AIC, AIC information criterion, mas maganda si model 3. Okay, how about ANOVA, guys? ANOVA. Okay, take a look at this, guys. Sino si unrestricted at saka sino si restricted? Okay. Remember, si model 3, ito yung binawasan natin. Diba? Ito yung binawasan natin ng gender. So ito yung restricted ngayon kasi anim na lang yung ano niya, anim na lang independent variables niya. Si model 2, 7 pa to, no? So this is very important kasi gusto nating para alam natin kung paano natin i-interpret yung results ng analysis of variance natin. Restricted model, model 3. This is the one that has only 6 independent variables. Si model 3 natin, si model 2 natin yung unrestricted kasi 7 yung ano niya. 7 yung explanatory variables. So let's run this. All right. So what do we have here? Okay. P-value 0.7971. So what will be our conclusion, guys? Reject the null hypothesis or fail to reject? Fail to reject the null hypothesis. Kindly answer please in the chat box. Kindly answer the chat box, guys. Do we reject the null hypothesis or fail to reject the null hypothesis? What will be our conclusion? Reject or fail to reject? 0.790, 0.8 guys, huh? Halos 0.8. Yeah, correct. Thank you, Migs. Thank you, Maya. That's correct, no? Yeah, you're correct, Migs. So tama, we fail to reject the null hypothesis. Bakit? Yung p-value natin, no? 0.8. Diba? Ano sabi natin? The standard rule is when the p is low, the null must go. Yung low p doon, yung 0.05. Okay, if the p-value of your f-stat is greater than 0.05, then we fail to reject this. So ano ibig sabihin nun, guys? Ano ba yung null hypothesis natin? Ang null hypothesis natin na yung restricted natin, ba? You must, a restricted model, which is the one with 6 independent variables, is better than the unrestricted. It's better than the 7 independent variables. Here, we fail to reject that. Ibig sabihin, hindi natin ma-reject na si 6 independent variables is better than 7 independent variables. We fail to reject them. Okay? Ibig sabihin, mas maganda yung ano, there's reason to believe that the restricted model, the one with 6 independent variables, perform better relative to the unrestricted model, the one with 7 independent variables. Okay? Pause muna ako, guys. Clear ba yun? Clear? Paki-chat naman please kung yes or no. Okay, good. Thank you. Thank you. All right. So, now, ano next step? Ano pa rin tayo, guys? Backward ano pa rin tayo? Backward na stepwise regression natin. Kasi stepwise regression tayo. We don't just remove all the insignificant variables one by one. So, sino yung susunod na living variable natin? Paki-chat please. Which is the next living, yung aalis na variable, yung aalisin natin. Flash yung model natin, model 3. Which will be our living variable. Okay, may isang answer. Numdet. Okay, Alistair. Maya, thank you so much. Alistair, bakit Numdet? Why? Okay, sabi ni Alistair. Okay, Alistair, pakishare naman sa lahat yung answer mo. Okay, it has the lowest p-value. Okay. Ano ko lang guys, clarify ko lang ha. It has the lowest absolute p-value. Kasi numerically, mas mababa itong negative 1.58 kaysa 1.3, di ba? Mas mababa, guys, arithmetically speaking, mas mababa yung negative 1.58 relative to 1.33. But sabi natin, we're using the absolute value. So disregard the negative sign, and then, so quantitatively, ang mas maliit dyan, 1.33. So we will have to remove 1.33. So that will now bring us to model number 4. Okay, so umuulit lang tayo ganito, no? So ang living variable natin si NAMDEP. Okay, take a look at this. Ang matitira na lang, 5 na lang. No? Education, experience, tenure, gender, civil status. Okay, wala na si race, no? Wala na rin si NAMDEP. Ang matitira na lang, education, experience, tenure, gender, civil status. Okay, so dalawa pa yung ano natin, dalawa pa yung categorical variable natin. Okay, so let's run model 4. Okay, so here we have model 4. 36.21. 36.21, tapos dito sa isa, 36.31. So, also guys, take note, 37.03, tsaka 36.82, always the model with the bigger number of larger number of independent variables will always have the higher multiple R squared. But we don't base it on the multiple R squared. We base it on the adjusted R squared. Okay, so if we compare model 3 and model 4, mas mataas yung adjusted R squared ni model 3, 36.31. Ito, 36.31. Ito, 36.21 lang. Okay? 36.21 lang to. So, the model number 3 was able to explain more the variability of your dependent variable. But let's see, guys, in terms of AIC. So, hindi lang natin tinitingnan yung adjusted R squared, pati itong AIC. Okay, dito, model 4, 36.38.6, ito 36.38.8. So mas mababa yung yung model number 4, yung AIC. So medyo nakikita natin dito may conflict ng konti, yung adjusted R squared at saka yung AIC. Okay? But we will be using AIC as the basis. So makikita natin dito na model number 4 is better. And then how about ANOVA? Check natin si ANOVA. Remember si model number 3, guys, this has 5 predictors. Model number 4 has only 4 predictors. Okay? So model 3, so this has 5 IPs versus model 4, this has 4 IDs. Okay? So, sino yung restricted natin dito? Ang restricted model natin is model number 4, yung mas konti. Ano yung null hypothesis natin? Model number 4 is better or is preferred to model number 3. Okay? So, laging ganun guys, yung restricted, yung mas konting independent variable, siya yung null hypothesis natin. Okay, so let's run this. Okay, ano lumalabas guys? 0.184 yung p-value natin dito. So we fail to reject the null hypothesis. Failure to reject the null hypothesis that model number 4 is better than model number 5. So mas maganda guys yung 4 lang yung independent variables compared to the one with 5 independent variables. This is better. Okay, based on our ANOVA. Okay, now question. Is there a need to create a model 5? Tingnan natin, guys. Asan ba yung model number 4 natin? Okay. Take a look at this. Oops, ano nangyari? You notice, guys, that whereas before sa experience, no? Sa experience dati sa model number 3 natin, significant siya. Pero at ano lang, at 10%. No? Tapos si civil status, hindi siya significant. Okay, but when we did stepwise regression in backward, notice na nagbago. No? Nagbago na yung result natin. Yung model number, this is now model number 4. And we notice, guys, that experience is now not statistically significant. Tapos si civil status ngayon, before, yung dati, hindi siya significant dati. But when we did stepwise regression, in particular backward na stepwise, naging significant na si single status. So that's why, guys, sa stepwise kasi, hindi pa pwede yung tatanggalin natin lahat ng mga insignificant. Tapos yun na yung final model. Kasi when you remove some variables, there may be changes in how one variable explains your dependent variable. Take a look at this. Diba? Kanina si experience yung statistically significant at 10%. Si civil status hindi. Ngayon, siya na yung si civil status na yung significant at 10%. Si experience na yung hindi. Okay, so what will happen here is that our living variable will be experience. So tatanggalin na natin si experience. Right? So mag-model 5 tayo. This one, model 5. So we now have education, tenure, gender, civil status. Tinanggal na natin si experience, si number of dependents, at saka si race, no? Tinanggal na natin yung 4 na yun, yung 3 yun. So let's run this. It's almost time, guys. So what happened? Okay, take a look, guys. Lahat sila significant na, di ba? Significant at 5%. If one was significant at 10%, then we will have to decide kung very important ba yung na 5% o 10%. Kasi pag mga medical field, medical yung subject, very important yung level of significance. Pero pag minsan mga econometrics or finance, minsan tinatanggap na rin at rinirelax ng konti yung yung level of significance sa 5% or sa 10%. Dito, significant na to at 5%, okay, significant at 0.1%, lahat. Okay, and if we look down, guys, 36% yung adjusted R-squared. Bumaba yung adjusted R-squared niya. Pero if you take a look, let's compare, guys, yung let's compare yung AIC ni model 4, AIC ni model 5. Si model 5, guys, yung mas konti yung di ba? Okay? Okay, take a look at this, no? Sa AIC naman, mas mataas yung AIC ni model 5, yung 4 na lang yung independent variables. No? Kaysa kay model 4, ito mas mababa yung AIC niya. No? So this tells us, guys, so should we accept now model 4 na lang? Okay, or model 5? So ang lesson dito, guys, do not just focus on one parameter. Do not just trust in your adjusted R-squared. Do not just trust or use your AIC. Kailangan i-compare natin. No? Let's see, mag-ANOVA tayo, guys. Mag-ANOVA tayo. And this will be the last one kasi time na, guys. 12:30 na. ANOVA. Let's see. Okay. So, sino yung model natin dito? Si model 5 natin, yung 4 na lang yung independent variables. Si model 4, yung 5 yung independent variables. So, ang natin dito, ang null hypothesis, model 5, okay, ito na rin 4 IVs, no? Is preferred to model 4. So what's our conclusion, guys? P-value 0.11. Therefore, we fail to reject this null hypothesis. So statistically, guys, in terms of statistical significance, mas maganda si model number 5. Okay? Yung lahat significant ito. Alright? So ngayon, from there, since ito na yung final model natin, we will now do diagnostics. Ito na guys. So gawin nyo yung diagnostics sa taas, yung, yung mod 1, diagnostic metrics. Okay, that's what we're going to discuss next next meeting. Quickly, let's take a look at yung ano natin, yung model natin in terms of heteroscedasticity, normality, etc. And then we're going to look at stepwise regression in greater detail. Papakita natin na pareho ito dun sa ginawa natin just now. Okay, let me stop recording.